Good day and welcome to these video lectures about algebra. In this video lecture, I will discuss how to solve word problems in an easy to understand. So let's start. In this video, we will be going to solve work-related word problems. Here is our problem. Ben can paint this foot wall in 40 minutes, while Peter can paint the same wall in 60 minutes. How long will it take for them to paint the wall together? Before we solve the problem, let me discuss first the concept on how to solve this type of word problem. In this type of word problems, it has a template to use for the solution. And it is like this. It is an equation which is composed of fractions on both sides. Now let me explain each part of this equation. The first box is the time it takes for person A. The second box is the time it takes for person B. And the third box is the time it takes for them together. In the problem, we have two persons involved. So the number of fractions in the left side must be 2. Let's say if the problem will involve 3 persons, the number of fractions in the left side must be 3. Notice that the numerator are all the same. It has all number 1 in the numerator. So what does it mean? It means that each person has one job to do, and even if they do the work together, they also do the same number of jobs. So the numerator will indicate the number of jobs. Now let's fill up the box. Let's call the time for Ben to finish the job alone as TB, for Peter as TP, and we call the time to finish the job together as TBP. Now let's solve the problem. The time of Ben to finish the job alone is 40 minutes, and for Peter is 60 minutes. Now for the meantime, let's call TBP as variable x. And to solve for x, we will get the least common multiple, or we call it LCM, and then multiply it on both sides of the equation. Now the LCM is 120x. After multiplying the equation will become 3x plus 2x is equal to 120, then 5x is equal to 120. Solving for x, we get x is equal to 120 divided by 5, which is equal to 24. So the time it takes for Ben and Peter to finish the job if they work together is 24 minutes. Now, to check if your answer is correct, just plug in the value of x to the equation and be sure that the value you get in the left side is equal to the value you get in the right side. Let's solve another problem, but this time it involves 3 persons. Here is our problem. John, Peter, and Ben can finish painting the wall in 2 hours. If John does the job alone, he can finish it in 5 hours. If Peter does the job alone, he can finish it in 6 hours. How long will it take for Ben to finish the job alone? The equations for the solution will look like this. Since we have 3 persons involved, the number of fractions in the left side is 3. Now let's solve the problem. The time of Jan to finish the job alone is 5 hours. For Peter is 6 hours, and for them to finish painting the wall together is 2 hours. The question is how long for Ben to finish the job alone. So we will call the time for Ben as x. To solve for x, we will get the least common multiple, or we call it LCM, and then multiply it on both sides of the equation. Now the LCM is 30x. After multiplying, the equation will become 6x plus 5x plus 30 is equal to 15x. Then add the common term, we get 4x is equal to 30. Solving for x, we get x is equal to 7.5. So the time it takes for Ben to finish the job alone is 7.5 hours. So again, to check if your answer is correct, just plug in the value of x to the equation and be sure that the value you get in the left side is equal to the value you get in the right side. Let's solve one more problem, but this time it involves filling and draining of tank. Here is our problem. A tank can be filled by bulb A in 3 hours and by bulb B in 5 hours. When the tank is full, it can be drained by bulb C in 4 hours. If the tank is initially empty and all the bulbs are open, how many hours will it take to fill up the tank? The equations for the solution will look like this. Since we have 3 variables involved, so the number of fractions in the left side is 3. Notice that we have 2 keywords to be considered, and these are the filling the tank and draining the tank. Keep in mind that filling is considered as positive while draining is negative. It is just like entering is positive while leaving is negative. Bulb A and B is filling the tank. That is why it is positive. While bulb C is draining the tank, that's why it is negative. Now let's solve the problem. The time for bulb A to fill the tank alone is 3 hours. And for bulb B is 5 hours. Now bulb C is draining, and the time for bulb C to drain the tank alone is 4 hours. Now the question is how many hours will it take to fill up the tank while all bulbs are open? So the time to fill the tank, we will call it as x. To solve for x, we will get the least common multiple, or we call it LCM, and then multiply it on both sides of the equation. Now the LCM is 60x. After multiplying, the equation will become 20x plus 12x minus 15x equals 60. Then add the common term, we get 17x is equal to 60. Solving for x, we get x is equal to 3.53. So the time it takes to fill the tank if all bulbs are open is 3.53 hours. So again, to check if your answer is correct, just plug in the value of x to the equation and be sure that the value you get in the left side is equal to the value you get in the right side. That's all. Thank you.